Thank you. What a beautiful venue here. I feel so guilty giving a very serious business presentation. It's really more suited to opera or comedy. So let's see if we can go here. Come on. All right, time for my favorite joke. How many engineers does it take to set up the AV system in a room? All right. Let's go. Today, I would like to talk about quality, but not just quality. In the words of Steve Ballmer, quality, 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 or as I like to refer to it, Q14. Someone pointed out to me that there's actually 15, so we're going to have to take a look at that acronym. I'm Chet Haase, and I want to talk about how you can achieve quality in your software organization, just like I have. So we have a full agenda to cover today. First of all, I'd like to tell you a little bit about me, because I'm sure you'd like to hear that. Next, I want to define what quality means to everyone globally, and then I want to talk about what quality means to me, because again, you care what I think. Then I'm going to cover a very important equation, because I think that any presentation is enlightened and made more important proportional to the number of Greek letters that you use in the presentation. Math is good for Greek letters. Then we're going to cover some important quality metrics, charts, and data, because we're engineers, we understand data, and data makes truth. Then we're going to cover some common misconceptions in quality, things that you probably think are true, and yet they aren't. And finally, what can you do to achieve this quality? But first, let's talk about me. I'm Chet Haase. I work for a company called Chet Haase Quality Consultants Incorporated. I am the president, the founder, the CEO, the COO, the CTO, and the chairman. I'm also a consultant and the sole employee. I've been doing many years in engineering and also many years in creating bugs. Now that's an important fact. We're going to get back to this. All those years I was doing software engineering, I was writing bugs. This is sort of software anonymous. My name is Chet Haase. I create bugs. However, for the past 4 years, I have been doing solely presentations on quality, which means that I am not writing code, which means I'm not creating bugs. And you're going to find out how you can achieve that same level of quality in your organization. Finally, I'd like to point out that this year I received a certificate of quality. I'd like to show that to you now. There's a couple of important things to notice about this. First is that it says quality not once, but twice. Next is my name, which means it's mine. And the third, I want you to notice the fine level of detail in this certificate. If we zoom in, you can see the level of quality just in the certificate. All right, so what do we mean by quality? Well, it's best to step back to the roots of words to really understand what their meaning is. If we break up quality into its Latin roots, we get qual, which means what? We get IT, which is IT. And we get Y, which is why? So if we put these together, it's what IT? Why? Which I think is pretty clear. But what does quality mean to me? So does it mean tests? Lots of different tests we could run. There's a load test. There's all these other kinds of tests that we could run all the time. Is that what we mean by quality? Yes, it is. You can't have quality if you can't verify that you have quality. Do we mean metrics? Do we mean graphs, important graphs showing that as the number of defects or bugs goes down, the level of quality goes up. Again, yes. Yes, we do. What about eliminating bugs? Is that what we mean by quality? No, it's not. Because to eliminate bugs, it means that you had bugs to begin with. That was your failure. Now, I want to talk about a quality process whereby you will have no bugs to begin with, therefore no bugs to fix. So here's an important equation that I want to cover. I call this the equivalence theorem of code, or ETSI. The number of bugs, represented by B, equals the number of lines of code times the number of files in the project times the number of statements times the number of condition statements. And we square all of this just because we should. It's a math equation. And the most important part is we introduce a sigma in here to take the sum of all of this as x goes from 0 to infinity. Now, why x is there, I don't know, but these summations usually use x. And they usually go to infinity. And then finally, this is probably the most important part, we add in an error term because we're software engineers. It's not really engineering, we're just making shit up. And then you get the definitive answer to the number of bugs. Now, the important thing to notice about this equation is that, of course, the number of bugs is directly proportional to the amount of code, as you see on the right-hand side. We'll get back to that. First, I want to talk about some important metrics. So, where do the bugs live in the code? There's lots of places that they could live in any project. They could live in the documentation. They could live in the specification to begin with. Maybe there's problems there. What about the memos that we send each other in the office, or the emails in which we describe software? Maybe somebody's desk drawers, perhaps on the monitors, on the Post-its where you write your password. Maybe it's in the conversations that we have in the hall, or the meetings that we have with other engineers on the team, or maybe, just maybe, they are all in the code. That's an important metric right there, and I know because I made it. So who writes the bugs in a software organization? What about the people in the sales team or marketing? What about the administrative staff? How about the security guard or the people that clean your offices? How about management? Now, there's an important point. We worked with an organization where management introduced some bugs. There were some managers who used to be engineers and thought that they could still write code, and so they did. They wrote the code, they introduced some bugs, and then they were no longer at the company. How about the accounting department? Probably not. What about engineering? That is where all of the bugs come from, right? So we're zeroing in on the core problems here, aren't we? All right, what about code versus bugs? Well, here's an important chart. So we worked with several organizations, we aggregated data, and we can see that over time, the amount of code in these organizations grew almost monotonically, right? Whereas the number of bugs grew exactly proportional to that. Except for an anomaly in the middle, you'll see that there was a dip in the amount of code and a rise in the number of bugs. Now, what was going on there? It turns out that an engineer made a mistake, deleted a whole crap ton of code, and caused even more bugs than they had before. Realized the mistake, next day checked the code back in, code went back up, so did the number of bugs. All right, so what we want, instead of all of this stuff going up all the time, is for the number of bugs to go down over time instead. And to do that, we need to bring down the amount of code. I think this is pretty obvious by now. All right, so here's some common misconceptions. There are things that you probably think you understand about software quality, and I'm going to prove you wrong. I call these the believable solutions, or BS. First of all, there's the creation of guidelines and the attainment of top excellence, or what I call cogitates. We first identify the processes by which we will write the code, and then we document these approaches very carefully. We form teams to discuss all of these processes and methodologies so that we all understand it. We present the findings to the overall department and organization, and then we have explicit training to teach engineering how to carefully follow the specifications, guidance, and processes. And then the engineers write the code. So if we look at all of the steps in the cogitate methodology, we can see that all of the ones at the top don't introduce bugs, because there's no code being written, and then the engineers write the code. That's where the problem lies. How about better specifications, or what I also call BS? We start by comprehensively itemizing all of the requirements for the projects. We identify the problems up front so we can see what's going to happen in the future. We identify it so we can do something about it. We propose solutions to those problems, and then the engineers write the code. Once again, we can see that all the top ones don't create any problems because nobody is actually committing code. However, the last one does. That's where all the bugs lie. Then we have the code review approval process, or CRAP. So here's the way you think code reviews work. There's an engineer that writes some code, and then there's another engineer that reviews that code, probably sees some bugs, makes some suggestions, then the first engineer fixes all those bugs, and then the engineer submits what should now be bug-free code because the bugs were caught by the reviewer, right? So it seems like there's probably bugs that were written to begin with when the engineer wrote, so yes, we're dead on there. And then there's a review, there's no bugs created because there's no code written. And then the engineer fixes the bugs, so there's no bugs. And then the engineer commits the code, no bugs, and we're all good. The way it actually works is they create bugs to begin with when they write the code. There's no bugs created in the review process. Again, if you don't write code, you don't write bugs. And then the first engineer writes some new code, creating new bugs along the way, and then they commit it, and there's more bugs created. Right? Are you following me through all this? It's very complicated. I wouldn't be surprised if you're lost. I am. All right, what about product management supervision, or PMS? In the PMS methodology, we have a product manager that identifies the features that customers require and then tells the engineering department to implement those features. Then they track the features through to implementation, typically by a process that goes something like, are we there yet? Are we there yet? Are we there yet? And then the engineer writes the code. So the first step, we identify the features, no code written, no bugs. We tell the engineer department what to do, no bugs are created. We track the feature implementation, no bugs are created. The engineer writes the code, and there's the bugs. Finally, we have work hours is never ending, which I call wine. In this one, the engineer writes some code, causes some bugs, feels really bad about it, stays late to fix those bugs. A for effort, F for result. Creates more bugs because they wrote more code. Then the engineer gets tired and writes even more code and creates more bugs. In fact, creates many, many more bugs because they're tired. And then the engineer falls asleep. No bugs. All right, so all of this boils down to the simple relationship that code leads to bugs. So, what can we do about this? In our organizations, how can we use this important relationship, which I, for the first time, have pointed out to you? So, I call this fixing the problem. The original acronym was FTP. I didn't like that, so now the acronym is HERO. So here's a typical software organization. I'm going to teach you about the reorg methodology. So we have management structure, we have a whole lot of engineers reporting into the managers. Engineers have workstations, they're all on some intranet going through a router that connects to the internet. Typity, 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 check in the code, bugs are created, right? So what can we do about this? First of all, we work with organizations to eliminate the internet. However, that doesn't go far enough because the engineers probably have other ways to access the internet. They probably just go to a coffee shop outside. So we make it a little bit harder for them to talk to each other. We eliminate the router and the intranet. So now none of these machines are networked. It makes it a little bit harder. However, they can still type. So then we start taking away their machines. However, they're engineers. They probably have more machines than toes. So eventually, we end up in all organizations that we work with that want to pursue quality, just eliminating the engineering department entirely. So there's another step that you can take in your organization. Organizations grow all the time. They need to hire more people. You always need more resources to achieve more productivity, right? Well, there's the methodology that I call hire more managers, or There are things that managers do, and there are things that managers do not do. They manage people. They don't write code. They attend meetings. They don't write code. They talk with other managers, and they don't write code. They facilitate cross-functional growth strategies and interdepartmental team facilitation for the purposes of collaborative interfacing and department-wide coordination, but they don't create bugs. So hire more managers. Start today, hire as many as you can. Don't use those heads on engineers. They're just going to create bugs. What about sales, you're saying? We still have to sell a product. We still need customers. We still need revenue to make the paychecks. How are we going to deal with this? I call this WAS. So here's the timeline of a typical product. You have release 1.0. It goes out there. Everyone's happy, but you realize there's bugs in there. So you release 1.1. There's still bugs in there, plus some new features need to be implemented, so you release 2.0, uh-oh, more bugs, 2.1, uh-oh, more bugs, 2.2, uh-oh, more bugs, 2.3, and this is when we have what I call the corporate realization of quality epiphany, or CORQ. This is when you realize that no matter what you do, you're just going to generate more bugs, but there's another solution. Right? You need a new release, but you don't need more bugs. So you simply release 2.3 again, but you call it 3.0. Now, you haven't fixed the bugs that are in 2.3, but it's very important you have not introduced more bugs along the way. You've reached a steady state, a bug equilibrium. And I don't know what the acronym for that is. After that, of course, you need a dot release because that's what customers expect and that's what they pay for. So again, you release 2.3 is 3.1, and on it goes. All right, so what you're asking, since you're probably all engineers in here, what about engineering? All of those engineers that lost their jobs in there. Okay, I call this we. So here's the progression. All of a sudden, you're not doing any more coding, which means you're not creating bugs, which means that you're creating more quality on a continuous basis, which means you're developing expertise in quality, which means now you are experts in quality. And now you can give presentations on quality. Just like this one. All right, we have a few minutes for questions. I hope we have some good questions in the audience. I'll see what I can do to come up with some good answers. So, this is the question period. I call this Q. Please. How can I solve your quality problems? I can't eliminate you from your organization directly, but I can certainly recommend that to your management. Anybody? Someone's got to be first. I'm not going to go away until someone asks a question or they kick me off the stage. Are there any conferences for managers? When all engineers have been eliminated, all of the conferences will be for managers. Thank you. How about QA? You know, you still need QA to verify that you have quality. As I said, tests are an important part of the quality process. So even if you're re-releasing 2.3, you still have to prove that it's release 2.3. So you keep the entire quality department, they just rerun the tests every time on the same code base over and over. They get so good at that job. They're fantastic at their job after the 50th time they've run the tests on the same release. Yep. Yeah, QA is great. Sorry, what? What if the QAs are engineers? You know, it doesn't matter if you're an engineer, as long as you do not write code. That's the important part. You can call yourself whatever you want. As long as you're not committing code, then you're not committing bad quality. I missed that entire paragraph. Can we? That is an interesting idea. Okay, so the idea is that you can have engineers and you can have them write code but not release the code. I kind of like that. It's devious. You keep them occupied, you keep them happy because they think they're doing something. Yeah.